Okay, so let's head to our next question. So in this question, we are studying a prohibited drug use for athletes. Now there's known this test is known to have a 5% false positive rate. And this means that there is 5% chance that a clean athlete who is a non-user of the drug would test positive for the drug. And there is also a 10% false negative test. This means if somebody, there's a 10% chance that a user on a not clean person would test negative. And we know that of the athletes, 4% have been using the prohibited drug. And we also, yeah, that's all we know. And we want to see if a random athlete tests positive, what is the probability that they have been using the drug? Okay, so let's write all the information that we have. So probability of having a user is 0.04. That means probability of having a clean person is 0.96. And so we can create this. So we can show this on a tree. So for my users, I'm gonna have a 0.04% probability. For clean people is 0.96. Now, if we do the test, there is a chance that they're gonna test positive and a chance that they're gonna test negative for each of these cases. Now, if a person is clean, when they get tested, they might get uh, a false positive test with a probability of 5%. This is when the test is making a mistake. And with a probability of 95%, test says this test is negative and they're not using any drugs. And for the users, there is a 90% chance that they're going to test positive, which is correct. And there is a 10% chance that they're going to test negative. Okay, so similar to before, we can multiply these values to find our joint probabilities. Okay, so we already have this information summarized here, and using that, we can go ahead and fill out our joint probability table. So as always, start with your 1, then we can go through each of the branches and fill out the table. So first, for the clean people, tests positive is going to be 0.048, tests negative 0.912, and I'm gonna use my calculator to add this. No, I can add them. No, I can't. 60, I guess. 0.96, I guess. Yeah, and for users, I have for the users who are testing positive, my probability is 0.036. And for those who are not using anything is 0.005. 0.004, sorry. Um, so this guy would be 0.04. This guy is this much, 0.916. And for the rest would be, I think it should be 0.1 minus 0.916 is 0.084. This is everyone who has tested positive. Okay. So now we know what is the probability of people testing positive. So this is what we wanted to compute. We wanted to compute what is the probability that an athlete has been using the drug given they test positive. Probability of being a user given they test positive. So I'm gonna use my Bayes' rule. So we just computed probability of positive, and in our numerator, we're gonna need to compute probability of user and positive. Now in our joint probability table, we already have this information. Okay, so we have this as being 0.084, and for user and positive, we know that it was 0.036. So this would give me 0.4286. So this is the final probability that we need to calculate. Now what I said that we can also write the formula here to represent our Bayes' rule. So what I just wrote is kind of like a simplification of the Bayes' rule, and this is the extent of which you need to use the Bayes' rule. So I'm not going to ask you to do something more complicated than this. But just as a complement, just to be more complete, I'm gonna also write my formula just so it reflects the Bayes' rule. So user given it is positive. So to find probability of positive, this is what I'm gonna do. So to find positive, I'm gonna look at positive given it's a user times probability of user plus probability of positive given it's clean times probability of clean. Okay, so I'm not doing something fancy. I'm just going through my tree and adding up two of the branches. So that would be this branch, the first branch, and also my second branch. That's going to give me probability of positive people. Now, in our nominator, we only want to focus on those who are actually a user. So that would be just these people times probability of positive given its user times probability of user. So what I did in my basically Bayes' rule was that I found all the branches that were positive. Okay, that would be my denominator. And on my nominator, I only focused on this lower branch who were actually a user. Okay, so this is just the extent that you're gonna need to use the Bayes' rule. So if you are confused by the logic behind it, you don't need to worry so much about it. Okay, so we just want to be able to apply it to questions like this. Okay, thank you guys.